So you might be wondering, what is a nutrition student talking about fire? Long story, but short story, there's cake, and I did bring some today. It's a chocolate mousse, hazelnut tiramisu, raspberry cardamom cheesecake. Fusion of flavors or facts is my thing, so let's dig in. My mom asked me what kind of cake I wanted for my graduation from soil science, and I said I want one without 43 grams of sugar per slice. She said, okay, you figure it out. I said, okay, I will. So I looked at my recipe books. I couldn't decide tiramisu or chocolate raspberry cheesecake, and a layer cake was born. This relates to tree density. So this is a LiDAR here, imagery of high density and normal density forests. So which would you rather spend your time in? This connects to soil because I'm hypothesizing that the excess vegetation might produce more leaf litter. This is a soil lab that didn't go so well in my undergrad. I was supposed to observe what happens by the root growth. And I didn't get to that point because my plant died because I had too much organic matter. So I had to do my report on my lab partner's plant here, who obviously did really well. The lesson I learned did not die, and that was that organic matter can inhibit water infiltration. So some factors that affect organic matter would be leaf litter type. So generally deciduous decomposes faster than evergreen. And then we have soil factors, which would be texture, microbial activity, and moisture. Weather and climate factors would be humidity, rainfall, and temperature. Decomposition is generally increased by sunlight and decreased by cold or moisture extremes. These affect what biodiversity we have in the ecosystem. So nature has a tendency for feedback loops and homeostasis, whether blood pressure or atmospheric carbon dioxide concentrations. So is there a possible feedback loop in the amount of organic matter present? And so my hypothesis, let's consider a ponderosa pine forest, which is a dry forest. And so first we have fire exclusion, which allows leaf litter accumulation and plant growth. And then we have, first the plants are happy. There's more shade and more litter, which means less water loss from the soil. Then we have too many trees tapping the water, and so then we have decreased soil moisture, and that can decrease organic matter turnover and organic matter loss. That can also reduce water infiltration when there's more leaf litter. And then we have stressed trees due to shade and drought, and this can reduce water. And then the trees shed their leaves, initially providing more leaf litter, and then they produce less leaves, and then that's less leaf litter. The sun can now degrade the organic matter, which offsets accumulation, and the sun can also dry out the soil. So if you've ever let a houseplant dry out too much, the soil shrinks and it doesn't wet up. I'm guilty. Last week was finals week. So now take this to a landscape scale. Maybe that gets less rainfall and more intense storms. That has clear impacts on fire and water resources. So high density forests are a hazard for fire crews because they can't navigate at night, and that's a crucial time for fire management because of higher humidity and comfortable working temperatures. And just generally, which would you rather be spending your time in? This looks like a really nice picnic spot. This looks like a labyrinth that I wouldn't really want to try to navigate that. So how does this connect to NASA? Soil moisture can be measured remotely, and NASA's UAVSAR on the right is an existing mission. Currently, Sentinel from the European Space Agency has the data, and in 2024, NASA will be launching the NISAR mission. It has a 6-day return interval, and it has a spatial resolution 3 to 10 meters, and it'll measure the top 5 centimeter moisture of the soil and 0 to 67 meter depth. You can find out more at these websites. And if you have any thoughts on this, I would love to hear. I had a lot more thoughts that I could add, but I've only got 5 minutes. And come join me, and I'll serve you some cake if you would like to discuss.